Hello everyone! So for today's video, we'll talk about binary ionic compound. Binary compound, it is composed in single metal ion and a single non-metal ion. Metal ion is a cation, which is positively charged, and a non-metal ion is called anion and is negatively charged. Different elements can have different charge. So we can easily recognize it by looking at the periodic table. So let us disregard the transition metals for a while.
Metal gas have zero charge, while fluorine group have negative 1 charge, negative 2, negative 3, 4, positive 3, positive 2, and positive 1.
So in my own way, to make it easily remember, I do it like this. I use my hands. So I imagine that these are the transition metals. Then in this side, this is the right side of the periodic table. And this another side is the left side of the periodic table. So I will count from left to right. Positive 1, positive 2, positive 3, 4, negative 3, negative 2, negative 1, and 0. In naming binary compound, we should write first the cation, then followed by the anion with suffix IDE. In a case of sodium and chlorine, we should write first the cation, which is sodium, then followed by the anion, which is chlorine, with a suffix IDE to make it sodium chloride. Another example is the lithium and bromine. So write the cation first, which is lithium, then followed by the anion, which is bromine. Then don't forget the suffix IDE to make it lithium bromide. In naming binary compound involving transition metals, the only difference is the cation, while the anion remain the same with the suffix IDE. For example, copper. Copper can be positive 1 and positive 2. So we should write it in Roman numerals like this. We should always remember that the lower charge is equal to suffix OUS, while the higher charge is equal to suffix IC. So the copper 1 will become cuprous, while the copper 2 will become cupric. So in writing chemical formula, there are 2 steps we need to follow. For example, potassium oxide. First step is I get the charges of elements involved. Second step is crisscross to become the subscript of the other. So it will become like this. So when the subscript is 1, we don't have to write it anymore. Another example involving transition metals is iron 3 oxide. So first step is get the charge of elements involved. Then crisscross to become the subscript of the other. So it will become like this. Now let's try to solve formula mass. But let us define first what is formula mass. So formula mass refers to the sum of atomic masses of all the atoms in a chemical formula. It is also known as the molar mass and is expressed in atomic mass unit or grams. In solving formula mass, there are several steps we need to consider. So let's try to solve the NiSO3, or also known as nickel sulfide. The first step is to identify the elements involved. These are nickel, sulfur, and oxygen. The second step is to count the number of atoms in a chemical formula or in the compound, which is the subscript of the compound. So nickel have 1, sulfur have 1 atom, and oxygen have 3. Now, let's multiply the number of atoms of their respective atomic masses. So nickel have 59 atomic mass, sulfur have 32 atomic mass, then oxygen have 16. Let's solve. Then 3 times 16 is equal to 48. The next step is we need to add these results to finally get the formula mass. So 59 plus 32 plus 48 is 139 atomic mass unit or grams. Now let's move in solving percent composition. In solving percent composition, there are steps we need to follow too. So the first step is solving the formula mass, which is this. Then the second is to divide the atomic masses of each element to the total formula mass. So let's divide. Next, we need to multiply it by 100. Then let's solve all. 59 divided by 139 is equal to 0.42 times 100. We'll get the total of 42% of nickel. Then 32 divided by 139 is equal to 0.23 times 100. We have 23% of sulfur. 48 divided by 139 times 100, we have the total of 35% of oxygen. So let's try to check if this percent composition of each element is correct. So let's add all. 42 plus 23 plus 35, so 100%. So it's a check.